This is for our next two pages, pages 5 through 8 in the book. We've got a 5 and 6, which is for how we charge things, and then page 7 and 8 is insulators and conductors. So we're going to start with how we charge things, and we need to talk about electron affinity. Where electron affinity is how much a particular substance likes electrons over some other substance. And the way we can tell which one likes one more than the other one is through this something called a triboelectric series. And you have it on page, you've got it on your page 6. Let me pull it out here for you guys. Not page 6, page 5. The triboelectric series, yeah. There we go. Okay, and this is it right here, and I'll zoom in a bit. Okay, so this right here is how much. If you're higher up on the list, then you are willing to accept electrons. You have more electron affinity. You like electrons more than something that is lower on the list. So, I don't know if you remember the other day when I rubbed this rubber rod with some rabbit fur, and it took. I'm pretty sure I showed you guys this because when I touched then I touched the little leaves here, and the leaf separated. And, well, the way I got this charged was by rubbing it with fur, and because fur is way down on the list, and the rubber is way up on the list, that the rubber would take electrons from the rabbit fur, and they would stay on the rubber. So this had a negative charge all over it, and that's how I was able to get the pieces of foil to separate by touching on that, and we'll explain more about that in a little bit. But this is how we charge things, and so. If you remember our Van de Graaff generator that we were running, and you touch it and you see the sparks fly from it. What's going on in there is that we have a brush at the bottom of the generator over there. Then in this rubber, let's draw that here. So we've got this brush with a and it's got a rubber band on it. Electron affinity. Okay, and there's this rubber band inside. And the rubber band is inside the dome, right? But this is the mechanic that's going on, is that it's spinning this rubber band past the little brush down here, and it's taking electrons from the brush and bringing them up to the dome on the Van de Graaff generator, on the sparky thing that we did over there. Right here is where we get a transfer of electrons. Electrons are running from this thing, and they get onto the rubber band, and the rubber band hits the top of the generator and creates this negative charge up on the top. Okay, so that's how we charge things. we rub them against other things, and that's how we create a static charge. They rub against other things, and we have a transfer of electrons. That's how clouds get their charge. That there's an actual the friction of the air over the ground actually creates a transfer of electrons from the surface of the Earth up to the clouds, and that's how we get lightning to form. Now, so once we have something that has a charge, it can usually sit on one of two things. It can either sit on an insulator or a conductor. Okay, and the differences here: an insulator, well, a conductor. We'll start with that. A conductor allows Okay, so conductor allows for the free movement of electrons through the material. Now, there are some consequences to this, some connotations to this. That if we get a charge on a conductor, okay, in particular if we get a negative charge or a positive charge on a conductor, because electrons are free to move, and like charges repel each other, what naturally happens is that we will get an even distribution of charge on the surface of our conductor, wherever it is. An insulator, on the other hand, if you get a charge on it, the charges can stay local. Where you can get a piece of an insulator that has a charge. Okay. Each one of these negative signs, it represents an electron. Does that make sense? That they're negative, so they're electrons? Yeah? Okay. Okay, so an insulating substance can actually have areas on it where there are positive and negative charges. And that's because insulators do not allow, they restrict the movement. Okay, so an interesting thing happens when we move a charge near a conductor as opposed to an insulator. That if we have this conductor, and this is what we did with our jar over here with the foil on it. That if originally we have all this negative charge distributed around it, and we move a charged rod, like we had with the rubber rod with the rabbit fur, towards it. All these negative charges, what happens to our negative charges? What do we know about like charges? Okay, they repel each other, right? Opposites attract, like things repel. So all these charges, if this is a conductor, if these charges get close to it, we get this situation. That the negatives stay on here, because this is generally an insulator. But over here we'll have all of our negative charges will run away from this and they'll go to the other side of the conductor, which leaves what on this side of the conductor? Yeah, if all the free electrons go to this side, then this side over here is actually going to have a whole bunch of positive. Well, not protons. It's a lack of electrons. Okay, where the atoms on this part of the conductor have fewer electrons than you have protons. But the protons themselves don't move. Right? All the electrons just run away over here. Okay, right. Okay, this is called induction. Okay, this process where you induce a charge over here and where you induce this charge, and this, actually I lied to you, this is not induction. Induction is different. This is polarization. Okay, where it creates an object that has a positive end and a negative end to it.
On the first thing where it says conductor right here,
Mm-hmm.
on the bar or whatever, are those minus or
Those are all negative charges. I color code them. Green, I usually do green as negative and red as positive. And if you're red-green colorblind, then I'm sorry. But I can usually get away with green and red. What's that? Okay. So, that's really about it for this one. Is that we have insulators that restrict the movement of electrons, conductors that allow for the free movement, and when you bring a charged article near a conductor, you create this polarization. You create a concentration of positive on one side and a concentration of negative on the other, which makes a polar object. Okay. And that should be enough for you guys to get through pages 5 through 8 in your homework tonight.